Hello, we are back again with Professor Shannon Gracie from Miracosta College. We will be covering 10.5 from Blitzer's Introductory and Intermediate Algebra for College Students text. And this covers multiplying more than one term and rationalizing denominators. And actually, this should say multiplying radicals. Sorry about that. And rationalizing denominators. So here we go. Why don't we warm it up? All right, pause the movie, see how you do. Good luck. Okay, let's see how you did. Remember that there's an implied 1 here on the x. So we will get x to the 1/2 plus 1 minus, well, let me do an extra step here. So this would be x to the 1/2 times x to the 1 minus x to the 1/2 times 3. So this will be x to the 1/2 plus 1 minus, and then we usually put the coefficient in front, so we'll have 3x to the 1/2. 1/2 plus 1 is 3/2, so your end result will be x to the 3/2 minus 3 times x to the 1/2. How'd we do? Awesome. Okay, now we'll be using this idea a lot, all right, in Part B. When you have the same terms, okay, in the binomial, but you have a different sign in the middle. So do you see how everything is the same in these factors except the sign in the middle? You end up with a difference of squares. So this will be x squared minus 5 squared, which will yield a result of x to the 2 times 2, which is 4, minus 5 times 5, which is 25. Now, I want you guys to start getting used to the formula for squaring a binomial. And what I mean is there's two formulas. A plus b squared is equal to a squared plus 2 times a times b plus b squared, and a minus b, the quantity squared, is equal to a squared minus 2 times a times b plus b squared. We're going to be using that quite a bit in the next section and a little bit in this section, and that is how I'm going to show these problems, all right, that require that. One other thing that we'll use a bit, not in warm-up C, but if you have the square root of something, we'll call it a, being squared, that ends up just being a, right? Because remember, the square root of a is a to the 1/2, and you're squaring it, which is a to the 1/2 times 2, which is a to the 1, which is just a. So what you got to remember is that when you square a square root, a quantity with a square root, you get the radicand, right? Okay, so I think we're ready to get started. Oh, here we go, Part C. So Part C, this will be our a is 3x, so we'll have 3x, the quantity squared, minus 2 times 3x, which is the a in this second formula, and then plus, or 1 second, times 1, which is the other end, plus 1 squared. So 1 is the b, and 3x is the a. So basically this formula here, a minus b squared, is what we're using. So this is the a, and then the b was the 1. And this was something that you've seen in introductory algebra, so you just might need to review it a little. I promise you, it might seem hard at first, but it's going to make a lot of the problems that are coming up easier for you. So here we go. This will be equal to 3x times 3x is 9x squared minus 6x plus 1, and we're done. Okay? All right, multiplying radical expressions with more than one term. Oops. So, radical expressions with more than one term are multiplied in much the same way as polynomials. With more than one term are multiplied. So, the main difference here is that you may be able to simplify some of the radicals after you're done with the initial multiplication. So let's see what we end up with here. So for part A, you are distributing the root 5 to this quantity. So we get root 5 times x plus root 5 times root 10. Well, this will give us x root 5, and then we can make this one happy square root and call this root 50, all right, using that product rule. Now, root 50 is, are there any perfect squares in there? Yes. There's a 25 in there. So this is like root 25 times root 2. So at the end of the day, we will get x root 5, and then root 25 is 5 times root 2. So the 5 came from evaluating the root 25. Okay, and that is the result for that problem. Alrighty, part B. We have the cube root of y squared being multiplied. And by the way, if you feel confident, feel free to pause the movie and try these out yourself so that you can get more practice. So this will end up being the cube root of y squared times the cube root of 16 minus the cube root of y squared times the cube root of y to the 1. So this will yield a result of the cube root of 16y squared, making one happy radical because they have the same index, minus the cube root of y cubed, because y squared times y to the 1 is y cubed. Now, 16 has a perfect cube in there. 8 times 2 times y squared. And then the cube root of y cubed is, great, it's just y, because it's y being cubed. So you bring that y out. And we will have the cube root, whoops, we can bring out the 2 because 8 is 2 cubed, and we'll have times the cube root of 2y squared minus y. And you want to make sure your radicals extend. You want to make sure that your radicals extend through the whole radicand, that they cover the whole radicand. All right. Part C Got a little bit more going on here. This will end up being 3 root 3. So I'm going to hold this one steady and we're going to distribute each of these terms. So 3 root 3 times 6 root 3 minus 3 root 3 times 10 root 2. So now the 4 root 2 gets distributed. So we'll have minus 4 root 2 times 6 root 3. Minus a minus is plus. 4 times 10 is 40. Well, actually, I'll just keep writing it out. Be consistent. 4 root 2 times 10 root 2. Okay, so far? Just keep everything, on track. Now, 3 times 6 is 18. Root 3 times root 3 gives you root 3 squared. Okay, and that's going to just be, 3. So we'll put that on the next one. And then 3 times 10 is 30. Root 3 times root 2 gives us root 6. And then 4 times 6 is 24. Root 2 times root 3 is root 6. And then 4 times 10 is 40. And then we'll have root 2 squared. All right, so this is going to give us 18 times 3. Root 3 squared just gives us 3. And then 30 root 6s, negative 30 root 6s minus 24 root 6s gives us minus 54 root 6s. And similarly, we'll have 40 times 2 because root 2 squared is 2. All right, 18 times 3 is 54. Minus 54 root 6 plus 80. Now be careful. You can't do the 54 minus 54 because you don't, you have to, in order to have like terms, you got to have a root 6. We can combine 54 plus 80 to get 134. And then we'll have minus 54 root 6 and we're all done. All right, moving right along. Example 2. This one we're going to bring some of the special multiplications. Let me make this a little smaller. That way we don't have to keep resizing it or scrolling. All right, so here do you guys see that we have, again, something that's going to result in a difference of squares? We've got an x on the left and a root 10 on the right, and they have this one has a minus and this one has a plus. So that's going to give us x squared minus root 10 squared. So this will be x squared, and then root 10 squared is perfect, 10. So again, this results in this. And that's our answer. Okay, so the first, again, difference of squares situation. So we'll have root a squared minus root b squared. So root a squared will be, it'll be a. And root b squared will be b. So you just get a minus b. Right, so this lined up with the root a being squared. And then this one here is the result of root b squared. All right. These are almost easier than the first example, huh? Okay, now we have a square. So this is the one where we're going to use the formula. The a from the formula is root 3. The b from the formula is root 15. So we'll have root 3 squared plus 2 times root 3 times root 15. So 2 times a times b. And then plus root 15 squared. So root 3 squared is, good, 3. And then this will be plus 2 times root 45. Good, because they're both square roots, so we can make one happy product. And then root 15 squared is 15. Combining the 3 and the 15, we get 18 plus 2. Now be careful. 45 has a perfect square in it. 9 times 5 is 45. So we get 18 plus 2 times, good, 3 times root 5. The 3 is from the square root of 9. So then we'll get 18 plus 6 times root 5. Because remember, when you bring anything out of a radical, you multiply it to the coefficient. And again, don't combine that 18 and 6, because the only way you'd be able to combine it would be if there was a root 5 with the 18. All right, now moving right along to conjugates. Okay. Radical expressions that involve the sum and difference of the same two terms are called conjugates. So in the example above, in part B, each of those factors were conjugates. Root A plus root B is the conjugate of root A minus root B, and vice versa. And the first one, x plus root 10 is the conjugate of x minus root 10, and vice versa. So if I had, for example, suppose I had root 2 plus root 5, and you fill in the blank are conjugates. What would you say? Good. Root 2 minus root 5. Okay. And then, if you multiply them together, they result in a difference of squares result. So if you do root 2 plus root 5 times its conjugate, root 2 minus root 5, you would get root 2 squared minus root 5 squared, which is 2 minus 5, which is negative 3. So the beauty of this is that when you generate a difference of squares situations, it gets rid of all the radicals, right? So we will do that when we're looking to rationalize either a denominator or a numerator. So, rationalizing denominators containing one term occurs, I did this a little differently, occurs when you rewrite a radical expression as an equivalent expression in which the denominator no longer contains any radicals. Okay. When the denominator contains a single radical with an nth root, multiply the numerator and the denominator by a radical of index n that produces a perfect nth power and the denominator's radicand. Okay, so let's start off easy in part A. We don't want the radical in the denominator. We only want them in the numerator because it's telling us to rationalize each denominator. So when you see rationalize, it means it wants you to get rid of the radical. And in this case, they're saying we don't want them in the denominator because it wants us to rationalize each denominator. All right? Now, we have to think to ourselves, let me do this in green. We need to think to ourselves, okay, what will yield a perfect square? Because the index on here is 2, so we need a perfect square. So we have 3 to the 1. Do you see that if we multiplied by root 3, remember root 3 times root 3 just gives us 3, which is a rational number. Hence, rationalizing the denominator. But in order to balance that out, we have to also multiply the numerator by root 3. So root 3 divided by root 3 is just 1. So we haven't changed the value, we've just changed the looks. So this here gives us 2 times root 3 over root 3 squared, which, as we've talked about before, is just going to be the radicand 3. And we're done. That's it. So it's always, really important to pay attention to the instructions that, they give you. Okay, so here I've got, remember that we're allowed, if we have a quotient, we're allowed to split them. So we have the cube root of 13 over the cube root of 2. Now, instead of wanting a perfect square, I want a perfect cube. So do you see that I have 2 to the 1 there right now? What would I need to multiply 2 to the 1 by to get 2 cubed? Good. I need to multiply this by the cube root of 2 squared, because 2 to the 1 times 2 squared is 2 cubed. And then I'll be able to pull the 2 out of the radical. So then I need to multiply this guy by the cube root of 2 squared as well. So in the numerator, I'm going to get the cube root of 13 times 4, because 2 squared is 4, over the cube root of 2 cubed. So 13 times 4, I believe, is 52. Is that right? So we'll get the cube root of 52 over 2. And we're done. We have created a situation where we have the rational number 2 in the denominator. Okay, so part C. Why don't you guys try part C and D and see how you do? Right? Pause the movie and give C and D a try. Okay, let's see how you did. Again, we're going to split this quotient into a quotient of square roots. So we have the square root of 5 over the square root of 6 to the 1, x to the 1, y to the 1. You guys see that's what we have? So in order to get a perfect square, I'm going to need to multiply by, good, 6 to the 1, x to the 1, y to the 1. So that, of course, is just 6 times x times y. So then in the numerator, we'll get root 5 times 6 is 30. Oops. Times x times y over the square root of 6xy squared, which is root 30xy over 6xy. Okay, next up we have we have an index of 4, so we want things that are raised to the 4th power. So notice that 8 is, we could rewrite that. Let's rewrite this real quick. This is equivalent to 4x over the 4th root of 2 cubed x to the 1 y cubed. So, in order to get 4th powers underneath that 4th root, we're going to need to multiply by the 4th root of, we need 1 factor of 2. How many factors of x? 1 plus, good, 3 is 4, so we get, that would give us an x to the 4th, and then we need 1 factor of y. So that's the 4th root of 2x cubed y. So then we will have 4x times the 4th root of 2x cubed y over the 4th root of 2 to the 4th, x to the 4th, y to the 4th. When we multiply those together, so then this will be 4x times the 4th root of 2x cubed y over 2xy. Are we done? Almost. We're almost there. Do you see that we can divide out a 2? We can also divide out an x. So we end up with 2 times the 4th root of 2x cubed y over y. And we're all done. Okay, so next up, rationalizing denominators containing 2 terms. So when the denominator contains 2 terms with 1 or more radicals, 1 or more, oh, okay, sorry, my bad. 1 or more square roots. So in this case, we're going to be dealing just with square roots, not any other index. Multiply the numerator and the denominator by, extra words, by the conjugate of the denominator, because the conjugate, as we talked about before, will yield a rational number. So here we go. Make sure you put parentheses around everything. So what is the conjugate of 1 minus root 3? Good. It's 1 plus root 3. You put the same ends, but you change the sign in the middle. And remember, it says to rationalize each denominator, so we're just looking at the denominators. Now, my advice to you, sometimes they can be a wee bit tricky. So sometimes it's good to leave the numerator in factored form until you see what your result in the denominator is going to be. Sometimes you can simplify things a little bit more easily. So 1 minus root 3 times 1 plus root 3 yields a difference of squares. So we'll have 1 squared minus root 3 squared. So that'll give us 12 times 1 plus root 3 over 1 minus 3. Continuing, we will have 12 times the quantity 1 plus square root of 3 over negative 2. So we can divide out part of that negative 2. We will get, it's now going to, we'll have this negative, so we'll have negative 6 times 1 plus root 3. And then if we were to multiply it out, we would have negative 6 minus 6 times root 3. So we have rationalized the denominator. Okay. Why don't you try part B and see how you do? Go ahead and pause the movie and try part B. Okay, let's see how you did. What is the conjugate of the denominator? Good, it is going to be root 11 minus root 5. So root 11 minus root 5. That will give us 6 times root 11 minus root 5 over root 11 squared minus root 5 squared, which will be 6 times root 11 minus root 5 over 11 minus 5. And we will have 6 times root 11 minus root 5 over 6. So notice that the 6 divides out to be 1. And at the end of the day, we get a result of root 11 minus root 5. Now, the denominator doesn't always end up being 1. It just ended up being kind of a coincidence. All right, so part C. You got to be careful in something like this. You might want to reread the directions to figure out what you're rationalizing. We're rationalizing the denominator. So the conjugate of the denominator is going to be 2 root 3 plus 7 root 7. So 2 root 3 plus 7 root 7. So notice that this is going to be a binomial being squared in the numerator, and there will be a difference of squares in the denominators. So 2 root 3 squared. Actually, I'm going to write one more step. So this is 2 root 3 plus 7 root 7, the quantity squared. I just want you to get used to using that formula. And then over here we'll have 2 root 3 squared minus 7 root 7 squared. This will be equal to 2 root 3, the quantity squared, I'm working again on the numerator, plus 2 times the product of the ends, plus the end squared. Now over here, be careful because you have to raise the 2 to the square as well as the root 3 to the square. So we'll have 4 times 3 minus 49 times 7. Okay, so then we will have 2 root 3 squared is 4 times 3. This will be 2 times 2 times 7, which is 28, and root 3 times root 7 is root 21. And then we'll have 49 times 7. That's all over 12 minus, let's see, 9 times 7 is 63. Oops, 63. I think we'll get 343. So we will have 12 plus 28 times root 21 plus 343 in the numerator. 12 minus 343 is going to be negative 331. We'll bring the negative out front. 12 plus 343 is going to give us, let's see, 355 plus 28 times the square root of 21 over 331. Then I guess we could just double check. No, 7 doesn't divide them. You'd want to double check that you couldn't, factor anything out and simplify, but I think we're safe here. All right. And the last example, here we go. The conjugate of the denominator is root x minus 3. We need to balance it out by multiplying the numerator by the same term. This will give us a result of root x times root x, or root x squared, however you want to put it. Because I don't think this one will simplify, which is why I'm kind of going on like this and not waiting. So then then we'll have minus root x times 3 plus 8 times root x. And then minus 24. And then we'll have root x squared minus 3 squared for our difference of squares situation. All right, so then the numerator will have x. 3 root x's, negative 3 root x's plus 8 root x's will give us 5 root x's. And then minus 24 over x minus 9, and we're done. Okay, and then the last topic for this section is rationalizing numerators. If you decide to go on to calculus, this can be very useful. So again, all along, we've been multiplying by 1. We've just been strategic in how we picked our 1. It looked a little messy sometimes. So to rationalize a numerator, again, we multiply by 1 to eliminate the radical in the numerator this time. So rationalize each numerator. Well, again, this is equivalent to root 3 over root 2. If I multiply this by the square root of 3 over the square root of 3, I will eliminate the radical in the numerator. This, of course, gives me root 3 squared over root 6, which is 3 over root 6. Okay. So just picking the numerator this time instead of the denominator to rationalize. All right, part B, we have a cube root. So what do we want under the radical? Perfect. Cubes, good. So our 1 that we pick will be the cube root of. We have a 5 to the 1, so we need a 5 squared. We have an x to the square, so we need an x to the 1. So then, this will yield a result of the cube root of 5 cubed x cubed over 4 times the cube root of 5 squared is 25, so we can write that as 25x. And then we can take out a 5 and an x from the numerator. And then we have 4 times the cube root of 25x in the denominator. And we're done. All right. Oh, I keep skipping to 10.6. All right, so now we've got 2 square roots. So we need to multiply the numerator and the denominator by the conjugate. So that'll be root x, good, plus root 2 over root x plus root 2. So then we will have root x squared minus root 2 squared. And I'm going to keep this in factored form to see if I can divide anything out. So we will get x minus 2, well, look at that, over x minus 2 times root x plus root 2. So notice that the x minus 2's divide out to be 1. And at the end of the day, we will get 1 over root x plus root 2. And that wraps up section 10.5. Have a fabulous day. And don't forget to work some problems from your homework set. Bye.